In this video, we are going to learn how to solve problems involving limits of a function using the Casio Fx-991 ES plus second edition scientific calculator in seconds for multiple choice questions under calculus. So ensure you stay to the very end of this video. As usual, you are going to learn a lot. So having known that, let's get started, guys. This is a Casio Fx-991 ES plus second edition scientific calculator. Now guys, the very first thing you will have to do with it to reset the calculator to put it in default mode. Alright, so to reset it, press shift this button 9, then press 3 for all, press equal to for yes, press equal to again. So right now the calculator is now in default mode. We have reset it. Okay, so the questions we have here, we have 3 questions to practice with. Okay, so let's begin with question 1. So evaluate the following. Now, this question 1, limit x is tending to 2. Alright, these are the values we are going to simplify when x is tending to 2. Now, guys, ensure you state the very last question I have here. Alright, so this question 3 here that is involving trigonometric identities, I'm going to say something different from how we are going to solve this question 1 and 2, alright, because of these 3 identities we have in the question. So ensure you stay till question 3 so that you will understand or get the idea on how to solve limits involving 3 identities like sine, cos, and tan. Okay, so let's begin question 1 once more. Now, the idea behind solving limits of a function using the Casio scientific calculator is to add a constant to the number the limit is tending to and store it on the calculator. Okay, now the constant I work with is 0.001. Guys, note it, 0.001. Alright, so in this question 1, the limit x is tending to 2, so we are going to add 2 to 0.001. okay, so once you do it, you press equal to, so we have it to be this. Okay, if you want to put it in decimal, if you press SD, it will change to decimal. So you store this value, you press shift this RCL, but it stands for store. So you want to store it as x, then press this S button and it will indicate that answer has been stored as x on the calculator. So we are good to go, guys. We're going to use this stored value now to evaluate this function of values we have. Let's impute the values. The numerator, we have it to be 4 minus 8x. You press alpha and this button for s to come out. Okay, plus 5x square, alright, minus x alpha and this button cube. So you press the use this power function. Okay, then over, we have 2x cube, make use of this power function. Okay, then minus 9x square. Okay, plus 12x. Okay, and minus 4. So that's it, guys. Let's now press equal and see what our output will be. So let's put it in decimal, guys. Let's put this in decimal. So we have it to be minus 0.33. So minus 0.33, guys, is same thing as this minus 1 over 3. Okay, so it's same thing as minus 1 over 3. So if you break down minus 1 over 3, you get minus 0.33. Okay, let's just check this, guys. So the correct option is option B. So when you break down minus 1 over 3, it will still give you minus 0.33. Okay, press SD. So minus 0.33. So it's as simple as this, guys. That's the idea. You add a constant to the value the limit is tending to, store it on the calculator, use it to simplify the function. Okay, so let's solve question 2 so that you will understand this. Now guys, for this question 2, we have to reset the calculator because we want to store a fresh number. Very important guys. So to reset, press shift button 9, 3, press equals and press equals again. So ensure that you reset the calculator whenever you want to store a new number. Okay, so this time our limit is turning to 3. So you add 3 plus 0.001. Okay, so they store this output shift store x. Alright, so the value has been stored. Okay, so let's use it to simplify the function. So it is numerator, we have square root of alpha x square, okay, plus x alpha x, okay, plus 3. Alright, you give space and put minus. Very important, give space guys. Then we have another square root of 4x, okay, plus 3. Then come down the denominator, we have it to be x to the power of 4. Alright, then we have minus 81. So that's it guys, let's press equal to. So we have 3.584 times 10 to the power negative 3. Okay, let's press SD and see what it's going to give us. Okay, so it's not changing to decimal value. This is the expression in standard form. If you want to put it in decimal, it will give you 0.00358. Okay, so let's simplify these options we have here and see the one will give us 3.584 times 10 to the power negative 3. Okay, so let's take option A. So we have 1 over 24. Okay, square root of 3. Enter. Press SD. No. Let's check option B. Let's just adjust it here, guys. Okay, remove this 3 here and put 15. Alright, then come to this place, remove this 24 and put 72. Very, very interesting, guys. Okay, remove this 2. So that's it. Press equal to. Exactly. So we have 3.58 times 10 to the power negative 3. So this will be the answer to this question. This was the value we got when we simplify the limit with the stored value. Alright, but let's check option C and see if we have something similar. So just remove this 15 here. Alright, and put 3 equal to. No. Last, let's check option D. This is interesting, guys. I play with this. Okay, so let's go to this place and put 24 just to be sure. No. So guys, the correct option is what? Option B. Alright, so it's as simple as this, guys. Hope you are learning something interesting from this video. So let's remove this. So remember, you have to reset a calculator, right? Because you're going to store a new number. So to reset, press shift this button now, put instructions. Okay, so it's not done. We have reset the calculator. So this time I want limit is tending to 0. So you're going to add the constant 0.001 to 0. Okay, store the output. Alright, so now guys, since this question 3 is involving 3 identities, you are going to solve this question under radian mode, not degree. The first two is solved. We are solved under degree, okay? And we got the right answer because they didn't involve 3 identities. But once the limit is involving pi or 3 identities, you have to ensure that you solve it in radian mode to get the correct answer. Alright, so to put it in radian mode, press shift mode. Radian is option 4. So we are good to go. So let's go ahead and solve the limit. Remember, we have stored the number already. So it's in fraction. We have sine 2x alpha x. Okay. close the bracket, we have minus tan 2x, okay, over x to the power 3. So that's it, guys. Let's press record and see what the output will be. So we have it to be this value. Alright, this is the expression in fraction, the output in fraction. Let's press SD to get the result or answer in decimal. Press SD. So we have it to minus 4.00, so which is equivalent to minus 4. You cannot approximate this, so it's something as minus 4. So the correct option is option C, minus 4. It's as simple as this, guys. This is basically how you can solve problems involving limits of a function easy and fast using the Casio Fx-991 ES Plus second edition scientific calculator for multiple choice questions under calculus. Hope you learned something interesting from this video. Let's call it a video here, guys. Don't forget to say once you're done, just press shift button 9, follow the instructions, press OK for all, press record and press record again. So we're good to go. In this video, we are going to learn how to solve problems involving derivatives or differentiation using the Casio Fx-991 ES Plus second edition scientific calculator in seconds from multiple choice questions. Now, after going through this video, I guarantee you guys that you'll be able to solve problems involving first derivatives using this calculator. So ensure you stay to the very end of the video. So having known that, guys, let's get started. So this is the Casio Fx-991 ES Plus second edition scientific calculator. Alright, so the very first thing you will have to do, guys, will be to reset it. Very important to put it in default mode. So to reset, just press shift button 9, follow the instructions, press 3, press record and press record again. So it's now in default mode. Next thing will be to ensure that the calculator is in radian mode. Very, very important, guys. So don't ever forget this. To put it in radian mode, all you have to do is to press shift this mode button, because by default it used to be in degree. So we press 4 for radian, so it's now in radian mode. You'll be seeing capital letter R on top of your calculator. It signifies radian mode. Okay, so let's begin with question 1. It says the function y equals 2x square root of 2 plus x. Okay, we have to differentiate this function. Now the idea behind solving derivatives or differentiating using the Casio calculator like this one is to store a number and use that stored number to differentiate the question. At the same time, you use the stored number to simplify the options to get your answer. Okay, so let's experiment this so that you understand it better. Now we're going to start to this calculator. Guys, I highly recommend to, okay, because I've practiced with 2 for a very long time now and have not found any error with it. You can choose to store any number you want to experiment with, but I recommend 2 for you guys to be on a safer side. So to start 2 on this calculator, press the number first 2, then press shift and this button LCL button stands for store. We want to store it as X, press this button for X and it will indicate that this value 2 has been stored as X on the calculator. So let's remove it. So let's go ahead and differentiate this function. To bring out the derivative symbol, press shift and this button. Okay, so derivative and differentiation are the same thing. So don't get confused when I say derivative. Okay, when I say derivative, I mean differentiation. The both terms are the same thing. Okay, so we have derivative of 2x alpha x, press alpha and this button for s to come out. Okay, square. Then we have square roots of, press this button, 2 plus x, press alpha and this button for s to come out. So that's it, guys. You have to ensure the brackets are balanced, guys. Very important. We have one bracket at the right and also one bracket at the left. So the brackets are balanced. Go over here and put the 2 restored. Okay, so we're good to go. Press import now. So we have 18. Right now we're going to simplify the options. Anyone that gives us 18 will answer this question. It's as simple as this, guys. So we begin with option A. It's a fraction. We have 5 s square alpha this square plus 8x. Press alpha and this button. okay, over square root of 4 plus x alpha and this button. So that's it, guys. Let's press equal to now. No, we got 18. So let's check option B. Let's just adjust it here, guys. So option B, you remove 4 here and put 2 for the denominator. Okay, you go up. We have, so it's the same thing. The values at the numerator are the same thing for option B. Okay, so let's press equal to, guys. 18 exactly. So guys, the correct option is what? Option B. This is how you can do this with a calculator. All right, so it's as simple as this. Let's solve question 2, guys. Now you guys will understand this better. So question 2 says find the derivative of tan inverse of 1 over s squared. So we press shift and this definite integral button. The derivative function will come out in the calculator. So we have tan inverse. Bring out tan inverse, we press shift and tan, it will come out. So tan inverse of a fraction 1 over x squared, press alpha and this button, then put square. So that's it, guys. Now the brackets are not balanced. We have 2 brackets at the left and 1 on the right. So we need to balance the brackets at the right. So you impute 1 more. So the brackets are not balanced, guys. Very, very important. Always ensure that you balance the brackets. Okay, so go back and put the 2 we stored, press equal to. So we have the derivative to be 0 minus 0.235. Okay, so right now we're going to simplify the options. Anyone that gives us minus 0.235 will be the answer. Okay, so let's remove this. Let's begin with option A. So it's the fraction. We have minus 2x alpha x, okay, over 1 plus x to the power of 4. Okay, so that's it, guys. Press SD to put this in decimal and 0.235 exactly. So the correct option is option A. Feel free to check option B and D, but I know that the right option is what? Option A. So guys, hope you are enjoying this video. Let's go ahead and solve the last question here before we call it a class. So let's move this. So question 3, we asked to differentiate the function y equals tan x sin x. So we press shift and this button for derivative function. So we have tan x alpha and this button for x. Okay, so guys, close the bracket here and impute sin x alpha and this button. Okay, close the bracket as well. Now let's check if the brackets are balanced. We have 3 brackets at the right, 1, 2 and 3, and we also have 1, 2 and 3 brackets at the left. So guys, the brackets are balanced, so we are good to go, guys. So let's go and put it to be stored. So press equal to, we have 6.15. so right now we're going to simplify the options. Anyone that gives us 6.15 will be the answer to this question. Okay, so let's read option A. So we have in option A, we have sin x, press alpha and this button. Okay, close the bracket, plus we have cot x. Now guys, notice that in trigonometry identities, cot is the same thing as 1 over tan. Okay, sec is the same thing as 1 over cos, and cosec is the same thing as 1 over sine. So we're going to replace cot here with 1 over tan since there is no cot on the calculator. So we have plus in fraction 1 over tan x. Remember we got 6.15 in the derivative. Okay, close the brackets, go over here and put this tan x alpha and this, close the brackets. So that's it for option A. Let's now press equal to get the output. No, so we got 6.15. Let's check option B, guys. Let's adjust it here. For option B, we have cosec here. So we're going to replace cosec with sine, 1 over sine. Okay, so that's what it means. So basically, let's just remove this and put sine x alpha x close the bracket. So that's it for option B. Okay, so right now let's press equal to no. So guys, let's check the last option. Option C. Option D is saying none, but it has to be option C. Let's check it, guys. Let's adjust it here and remove this. Put sec is same thing as cos, so we put cos x alpha x close the bracket. So that's it, guys. This is what we have. Alright, so let's press equal to now. 6.15 exactly. So guys, the correct option is what? Option C. Is as simple as this. This is basically how you can solve problems involving derivatives or differentiation, particularly first derivative using the Casio Fx-991 ES plus second edition scientific calculator in seconds for multiple choice calculus questions exam. Okay, so hope you learned something interesting from this video. Let's close the video, guys. Don't forget to reset the calculator once you're done. Just press shift button 9, full instructions, press 3, press equal to, press equal to again. So it's now cleared. Thanks for watching. In this video, we're going to learn how to solve problems involving second derivative using the Casio Fx-991 ES plus second edition scientific calculator fast and easily. Alright, for your multiple choice questions under calculus. So ensure you stay to the very end of this video. Alright, so having known that, let's get started. This is the Casio calculator, the second edition Casio FS and our ES plus. Alright, so the very first thing you have to do is to reset it as usual, guys. Very important to reset. Press shift button 9 for the instruction. Once reset all, press 3, press equal to, and press equal to again. So it's now reset, guys. Now the next thing you will have to do will be to ensure that the calculator is radian mode. Very important, guys. Whenever you're solving derivatives or differentiation, always put the calculator in radian mode. By default, it used to be in degree. So to put it in radian, press shift this mode button. Our radian is option 4. Press 4. Okay, it's now in radian. Now the next thing we are going to do will be to store a number, of which I highly recommend to guys. You can choose to store any other number aside 2, okay, but I recommend 2 to be at the safer side because I practiced with 2 for a long time. I have not found any error with it. Alright guys, to store 2 in the calculator, you press the value. Want to store it as X, you press shift this button. RCL button stands for store. So since you want to store it as X, you press this button for X and it will indicate that 2 has been stored as X on this calculator. So okay, we are good to go. Now the idea behind solving derivative with a Casio calculator is to use a stored value, of which we have already stored 2. So right now we're going to use this 2 we have stored to differentiate the function and also use the same value we stored to simplify the options to get our answer. So let's do it together, guys, so that you understand this better. So let's bring out the derivative function on the calculator. To do that, press shift this definite integral sign button to come out. So we have given the function f of x equals 3 over 4x plus 5. Find y double prime. Alright, so this y double prime signifies second derivative. Okay, so replace y double prime with the 2y over dx2, just like in this question too. Alright, so don't get confused with these terms, they mean the same thing. So it's in fraction, a function. We have 3 over 4x alpha and this button for x, okay, plus 5. Alright, so that's it. Go by and put the 2 we stored, okay, and also ensure that the brackets are balanced. We have one bracket at the right and so one bracket at the left, so the brackets are balanced. Very, very important, guys. Let's press equal to now. So we have this output, okay. Now, since we are solving second derivative, guys, look at what you're going to do next. Firstly, this value we have here, you are going to store this as alphabet A on a calculator. So to store it as alphabet A, press Shift Store. Alright, look at A alphabet here under this button, and it will indicate that this value has been stored as alphabet A on the calculator. Okay, so guys, let's go back. You press this arrow button, alright, and it will come to this very place. Then you adjust and add this constant here plus 0.00001. Alright, so this constant you will add it this to here and press equals again, so it will give you this. You then store this value as B. Alright, alphabet B, press shift. Alright, this store button, look at alphabet B here beside A. So it has been stored as alphabet B. We are good to go. So let's remove this, guys. Right now we are going to impute this value. Follow me, guys, step by step. You understand this. So right now we are going to do the alphabet B minus alphabet A. So to bring them out, press alpha and this B will come out, okay, minus alphabet A. Alpha and this is will come out over the constant we added to the 2 we impute at the derivative level. So the constant was 0.00001. Okay, 5 zeros. Take note, guys, very important. Press equal to. So we have 0.043. Right now we're going to simplify the options. Anyone that gives us 0.043 will be the answer to this question. Alright, very interesting. So let's begin with option A. Remember, we got 0.043. Okay, so we have 6 in brackets 4x, okay, plus 5 to the power 3. So that's it for this option A. No. Now let's check option B. Just put 96 here. Alright. No. So let's check option C. Is in fraction. So we have 6 over in bracket 4x plus 5. Close the brackets, the power 3. So that's it, guys. Press equal to. Put it in decimal. Press SD. No. So last, let's check option D. Let's adjust it here, guys. So the difference is you put there and put 9 and put 9 to make it 96. Okay. Press equal to. Put in decimal. 0.043 exactly. So the correct option is option D. It's as simple as this, guys. So hope you are following what I'm teaching or explaining in this video. Let's go ahead and solve question 2. Okay, so for question 2 we have if y equals 3 cos 3x, then the 2y over the x2 is what? Still second derivative. So right now let's bring out the derivative function. I press shift and this button. Okay, so we have 3 cos 3x, press alpha and this button, close the bracket. Alright, so the brackets are balanced, 2 at the right and 2 at the left. Go by and put the 2 restored. So that's it, guys. We're good to go. Press equal to. So we have this value, this output. We store this as A. Alright, press shift this button. Look at the A button. So the value has been stored as A. So let's go back, press this upper arrow key. So go to this place and add the constant here plus 0.0000150, guys. Press equal to. So you store this one as B. Shift store. Look at the B alphabet here, this button. Okay, so it has been stored. Let's go back now and impute alpha B minus alpha A, okay, over the constant 0.00001. So that's it, guys. Press equal to. We have minus 25.92. Right now, we're going to simplify the options. Anyone that gives us minus 25.92 be the answer to this question is as simple as this, guys. So let's do it together, guys. Okay, remember we got minus 25.92. So let's begin with option A. We have minus 27 cos 3x. Okay, close the bracket. Press equal to minus 25.92 exactly. So the correct option is what? Option A. So this is basically how you can solve problems involving second derivative using the Casio Fx-991 plus second edition scientific calculator in seconds and fast for multiple choice questions. Hope you learned something interesting from this video. Alright, let's call it a video, guys. Don't forget to reset once you are done. Just press shift button 9 for the instruction. Press 3, press record and press record again. So that's it. In this video, we are going to learn how to solve problems involving definite integrals using the Casio Fx-991 ES Plus second edition scientific calculator in seconds for multiple choice questions. Alright guys, so ensure you stay to the very end of this video. Okay, so having known that, let's get started. This is the Casio Fx-991 ES Plus second edition scientific calculator. Okay, so we have 3 questions to practice with, of which after solving these 3 questions here with you guys, you'll be in a better position to be able to solve similar problems you encounter on definite integrals. Alright, so let's begin with question 1. It says evaluate the following, and the upper limit is 2, lower limit is -1. Alright, so guys, definite integrals are integrals that have upper and lower limits, and they are usually straightforward. Okay, you don't need to store any number to solve them, unlike when solving indefinite integrals. So let's go ahead and solve question 1. Firstly, you need to reset the calculator to put it in default mode. Guys, very important. So to reset it, just press shift button 9, follow the instructions, you press 3, then press equal to and press equal to again. So we have now reset it. Next step is to ensure that the calculator is in radian mode. Guys, this step is very important. Don't ever forget this particular step. Okay, so to put it in radian mode, because by default this calculator used to be in degree, so to put it in radian mode, just press shift this mode button. So radian is option 4, press 4. Alright, so it's now in radian mode. So let's go ahead and solve this question 1. This is definite integral. You press this button for this definite integral. Okay, so the upper limit is 2, the lower limit is -1. Alright, very straightforward, guys. So go to this center box and impute the values in fraction. We have 1 minus 3x. Press alpha and this button for x to come out over. We have x square alpha and this button for x. Then press the button for square. We have minus x alpha and this button -6. So that's it, guys. Now let's press equal to and get our output or results. 0.277. So the correct option is what? Option A. Is as simple as this, guys. So let's go ahead and solve question 2. Let's wipe this. So question 2, definite integral of the upper limit this time around is 2. Okay, still 2. The lower limit now is 1, not -1. So we go back to the center box and impute the values. We have 3x squared, we press alpha and this button, then put this for square. So we have square root of s cubed plus 1. Bring out square root, we press shift. Okay, don't press shift, guys, just press this button. It will come out. Alright, so we have square root of x cubed, press alpha and this button, cube, make use of the power function. Alright, come down, we have plus 1. Alright, so that's it. This is what we have here, guys. Alright, so let's press equal to and get the output. This D stands for function. Okay, so we have it to be what? 16.11. Option A is the answer to this question 2. Okay, so we're making progress, guys. Let's solve the last question, and after it, we call it a class. Let's quickly solve this question 3 and call it a class. So let's remove this. Question 3 says the definite integral of, so you press this button. The upper limit now is pi. To bring up pi, press shift and this button, okay, over the lower limit is 0. Alright, come over to this center box and input the values. We have 5 cos square x. Now look at how you're going to represent this on the calculator. Pay attention here, guys. If you miss it here, you will fail it. Okay, so cos square x is the same thing as cos. Okay, you put the x now. Okay, close the bracket and then put the square. Alright, so this is how you're going to represent it on the calculator, or you do cos x times cos x. Okay, but I prefer this pattern, is easier. So let's proceed. Then we have sine x, impute sine x, alpha and x, close the bracket. Alright, so we are good to go, guys. Let's now press equal to and get the output. Very, very simple, guys. So we have it to be what, 10 over 3, which is what, option A. Alright, so this is how you can basically solve problems involving definite integrals, easy and fast, using the Casio Fx-991 ES Plus second edition scientific calculator for multiple choice questions in calculus. Hope you learned something interesting from this video. Okay, so let's call it the video, guys. So don't forget to reset the calculator to clear it. Once you're done, just press shift button 9, 0 for all, equal to again. In this video, we're going to learn how to solve problems involving indefinite integration using the Casio Fx-991 ES Plus second edition scientific calculator. Alright, so we have 2 questions here to practice with, of which after solving these 2 questions here with you, you will be in a better position to be able to solve problems you meet involving indefinite integration for multiple choice questions using the Casio Fx-991 ES Plus second edition. So having known that, let's get the calculator now and get started. Alright, so guys, this is Casio Fx-991 ES Plus scientific calculator, the second edition. Alright, now the very first thing you will have to do will be to reset the calculator. Very important, guys. The essence of resetting the calculator is to put it in default mode to remove whatever previous value you might have stored on it. So to quickly reset this calculator, all you have to do is to press shift then button 9. When you look at button 9, you will see clear written on top of it CLR. Okay, press shift and button 9, follow the instructions. Want to clear all, press 3, then press equal to for yes, then press AC key or equal to again. Let's press equal to. Alright, now we have cleared the calculator, is now in default mode. The next thing you are going to do will be to put the calculator in radian mode, guys. Very important. By default, this calculator used to be in degree. Alright, so when solving problems around integration and differentiation, guys, you are expected to always solve them in radian mode using this calculator or any calculator at all. Alright, so to put it in radian mode, just press shift this mode button, then option 4 is for radian. Okay, press 4. Alright, so it's now in radian. When you check carefully, you will see capital letter R written on top of here. It changed from capital letter D to R, showing that it's now in radian mode. Okay, so guys, we are good to go. Now, this is question 1. It says find the indefinite integral of 2x squared plus x cubed. Alright, in brackets. Now guys, the idea behind solving indefinite integration with a scientific calculator like this is to store a number and use that stored number to simplify the question, and also use the same stored number to differentiate the options to get your answer. Alright, now guys, you can choose to store any number you want, but I highly recommend 2, that you guys should be working with 2, because I've practiced with 2 for a long time now and I haven't found any error with it. Alright, so to start 2 on the calculator, just press 2 number, then press shift, then this button, RCL button. When we look at it carefully, we see STO on top of it stands for store. We press shift and this button. We want to store it as X. This is the S button. Alright, so once we press shift this button RCL, then press this button where S is. X is written in pink color on top of this button. Okay, so once you do it, it will indicate here that this value has been stored as X on the calculator. 2 has been stored as X. So we are good to go now. Let's use this stored value to simplify this question we have here, question 1, this indefinite integral. So we have 2, or is in bracket, guys. Let's just represent what we have there. Alright, so we open bracket, we have 2x. To bring out the x is stored, press alpha and this button again to come out 2x square, okay, plus x alpha this will come out cube. So we press shift and this button, x square button, cube will come out, close the brackets. Alright, so that's it. Let's press record now and see what we're going to have. So we have 16 right now. We're going to differentiate the options. Anyone that gives us 16 will basically be our answer. It's as simple as this, guys. Okay, so let's begin with option A. To bring out the derivative function on the calculator, you press shift and this button. Okay, so option A is in fraction. Make use of this button for the fraction. Very important, guys. So we have 2x cubed alpha this button. Okay, let's make use of power function thing in p cube. Okay, over 3. Alright, come over here. We have plus another fraction. Okay, we have s to the power 4 alpha this power function. Okay, over 4, and we have plus c. Now guys, this plus c is just a constant that is usually attached to the answers of indefinite integrals. So you don't need to put it here on the calculator, just ignore it. Then come over this place and put the 2 you stored. Very important, guys. Now, one more thing is that you have to ensure that the brackets are balanced. Very important, guys. Once the brackets are not balanced, you will basically end up having syntax error by the time you will be pressing equals button. Alright, so ensure that the brackets are balanced. Here, guys, we have one bracket at the right and also one bracket at the left, so the brackets are balanced. They're good to go. Let's press equals now and see if we're going to get 16, the value we got when we simplify the question. 16, correct. So the right option to this question 1 is option A. Now feel free to check option B and option D to see if you're going to have a closer value. Alright, but I know that you're going to get the wrong value. Alright, the correct option is what? Option A, which is the option that gave us exactly 16 we got when we simplify the question. So it's as simple as this, guy. This is the idea. Alright, so let's solve question 2 before I call it a class. Now you guys understand this concept very well. Let's go ahead and solve question 2. Okay, so we have evaluate the indefinite integral of s to the power of 4 ln x dx. So let's use this stored value, which is 2 here, to simplify the question. So the number you stored will not go out until you reset the calculator. Okay, so it's still here on the calculator since we have not reset the calculator. So we have s to the power of 4 here, alpha for question 2. Okay, the power of 4. You come down, we have ln x, look at ln function x alpha x, close the bracket. So let's press equal and see what we're going to have. 11.09. Okay, so right now we are going to differentiate the options. Anyone that gives us 11.09 will be the answer to this question. Very, very simple, guys. So we press shift for derivative and this button for derivative function. So let's begin with option A. We have in fraction x to the power 5 after this, okay, over 5. Then we have lane x, alright, close the bracket, okay, minus infraction x to the power 4, okay, over 5. Alright, so we also have lane x after this. Alright, close the bracket. The plus c, we don't need it. So let's ensure the brackets are balanced. Very important, guys. We have 3 brackets here at the right, 1, 2, and 3. We also have 3 brackets at the left, 1, 2, and this 3. Okay, so we are good to go. Let's go back here now and put the 2 restored. 8.25, no, we got 11.09. So let's check option C. Option B is saying none. Alright, let's just adjust it here, guys. There's no lane at this side of the expression, so remove this lane here. Okay, so we have at the denominator for option C, we have here we have 25. Okay, and the numerator we have x to the power 5, not 4, put 5. Okay, so that's it. What we have here is still correct. So guys, we are good to go. Let's press report now and see what we're going to have. The bracket is balanced. We have 2 at the left, we also have 2 at the right. Okay, let's press report. 11.09 exactly. So guys, the correct option is what? Option C. Feel free to check option D, but I know that you're going to have the wrong output. So this is the idea behind solving indefinite integration fast and easily using the Casio Fx-991 ES Plus second edition scientific calculator. Alright, in seconds per multiple choice questions. Hope there's something interesting from this video. Alright, let's call it a video, guys. Don't forget to reset the calculator once you are done. To put it in default mode, just press shift button 9 and press 3 for all, press record and quote again. Okay, so we are good to go, guys. Thanks for watching. In this video, we are going to learn how to solve problems involving trigonometric integrals using the Casio Fx-991 ES Plus second edition scientific calculator. In seconds, some multiple choice questions. Now, after going through this video, I guarantee you guys that you'll basically be able to solve or deal with any problem involving trigonometric integral using the Casio scientific calculator, the Casio Fx-991 ES Plus second edition. Alright, so having known that, let's get into the details of the video. If you check carefully, you will notice that we have 3 questions to practice with. Okay, so guys, these questions are not common. Alright, these are deeper questions, so ensure you stay to the very end so that you will understand step by step everything I'm going to show you or explain in this video on how to go about problems like this. So let's get the calculator now and get started. So this is the Casio Fx-991 ES Plus second edition scientific calculator. As usual, the very first thing you have to do is to reset it, guys. Very important to put it in default mode. So to reset, press shift button 9, full instruction, press 3 for, or press equal to and press record again. So we have now reached the calculator. The next thing will be to put it in radian mode. By default, it used to be in degree. Alright, so to put it in radian mode, which is the ideal mode for solving problems involving integration, differentiation under calculus. So you press shift this mode button. Radian is option 4. Alright, so it's now in radian mode. Okay, so guys, let's begin with question 1. Question 1 is definite integral, which is the type of integrals that have upper and lower limit. So to solve this, just press this integral sign button to come out. So what's the upper limit here? The upper limit is in fraction. Make use of the fraction button. So we have pi over 4. To bring out pi, we press shift and this button, pi will come out over 4. Okay, then the lower limit is in fraction as well. We have minus negative pi, press shift and this button for it over 4. Okay, then come to this center box and input the values. We have log. Okay, sec theta. Now guys, I know sec on the calculator. If you check here carefully, you will notice that I noticed something, that sec is the same thing as 1 over cos. Okay, so sec theta is the same thing as 1 over cos theta, where theta equals x. Okay, whereas cos sec theta is the same thing as 1 over sin theta, cos theta is 1 over tan theta. So since there is no sec on the calculator, we are going to replace sec with 1 over cos theta, which is the same thing with sec theta. So in fraction now, we are going to do 1 over cos theta. Remember our theta is x, press alpha and this for s to come out, close the brackets. Okay, so that's how you do it guys. Then we have minus tan theta. Theta is x, alpha and x. Alright, close the brackets. So this is what we have here guys. You need to ensure that the brackets are balanced guys, very important. Okay, we have how many brackets at the left? We have 2 brackets at the left. Okay, so at the right, so complete it, you add 1 more bracket here. So guys, the bracket are not balanced. We have 2 brackets at the right, and we also, sorry guys for this. Okay, so we have 2 brackets at the right, and we also have 2 brackets at the left. Okay, this one and this 2, then this one, this 2 for the right. Okay, so you go here now, let's press equal to guys and see the output. All right, so we have it to be what, 0. So the option to this question is what, option B. Very, very important guys. So that's the correct option to this question, option B, 0. So it's as easy as this guys. Now let's solve question 2. Okay, so question 2, let's move this. So question 2 says evaluate the definite integral of, let's bring out the definite integral sign. So the upper limit is in fraction. We have pi, okay, over 4. Then the lower limit, we have it to be 0. Then come to this side, the center box is in fraction. We have sine 2 theta, which is sine 2x, theta is x guys, close the bracket, over, then we have cos to the power of 4 theta. Now guys, another way you can represent this in a calculator, cos to the power of 4 theta, is by do it like this guys. Cos theta is x, right? Alpha x, close the bracket and put the power 4. Alright, so cos to the power of 4 theta means we should do cos theta times cos theta times cos theta times cos theta up to 4 times. So instead of wasting time doing it like that in the calculator, just represent it like this, is the same thing. Okay, so cos x in bracket to the power of 4 is something as cos to the power of 4 theta. Alright, is as simple as this guys. So plus we have sine to the power of 4 theta, which you're going to do sine x alpha x close the bracket to the power of 4. So that's it guys, we are good to go. This the theta is something as dx, we represent what function, so the nothing else we need. Okay, so let's press equal to now and see the output. So we have 0.78. Right now, the options are in pi. Okay, so let's break down these pi values we have and see the one that will give us 0.78, and that would basically be the answer to this question. So let's begin with option B is in fraction alpha and this button, okay, over 8 press equal to. So to change this to decimal, you press SD. No, we got 0.78. So let's check option C. Okay, let's just adjust this here, guys. Remove this 8 and put 4. So that is it. Press SD. Exactly. So 0.78. The correct option is what? Option C. It's as simple as this, guys. Now let's solve this last question, and after you can call it a color. This one is indefinite now, not definite. So ensure you watch this very well. I want to do now. Let's solve this one together, guys. And let's go ahead and solve question 3. Okay. So this time I want now we will. Okay, this time I want to solve indefinite integration. Now for indefinite integration, we need to store a number, of which I highly recommend 2, guys. So be working with 2. You can choose to experiment with any other number, but I recommend 2 to be on the safer side. So to store 2, you press the value, press shift, and this button L button stands for store. Okay, want to store it as X, you press this button for X. So once you do it, it indicates here that 2 has been stored as X on the calculator. So right now we're going to use this 2 restored to simplify the question, and also use the same 2 we have stored to differentiate the option to get our answer. So let's do it quickly, guys. Very, very simple. So in the question we have exponential to the power X. To bring out the exponential, press shift this button to the power of X. To bring out X, press alpha and this button. Okay, calm down, guys. Okay, so right now we have sec, okay, X. So sec is something as 1 over cos. Alright, so you put it in fraction. But guys, let's do it like this. If I just press this now, you're going to have this. Okay, I don't want it to get confused with this. Rather, let's firstly impute the fraction first for sec 1 over cos. Okay, 1 over cos x. Close the bracket, then come to the back of this place and impute the exponential. Shift this button. Okay, alpha and this for x to come out. So that's it, guys. So come over here and in brackets we have 1 plus tan x alpha this. So close the brackets. Alright, so ensure that brackets are balanced. Very, very important, guys. So this is what we have. The dx stands for function. So we have how many brackets at the right? We have 1. Okay, just 1. On the left we have 1, 2. Okay, so to balance the bracket at the right, we need to add 1 more to make it to 2. Okay, so it's now balanced. We are good to go, guys. So let's press equal to now and see what we're going to have as the output. 21.04. So right now we're going to differentiate the options. Anyone that gives us 21.04 will be the answer to this question. So it's as simple as this, guys. So let's begin with option A. To bring out the derivative function, press shift and this button. So we have exponential to the power of x sec x. So let's just press 1 over cos for sec x, okay, before we put the exponential. So we have a fraction 1 over cos x alpha x, close the bracket. So let's go over here and put the exponential. Alright, so we have exponential, press shift this button, the power of x. Alright, so that's it. That's for option A. A plus C is just a constant attached to the answers of indefinite integrals. So you don't need to impute it on the calculator. Okay, so we are good to go. The brackets are balanced. Go over here and put the 2. restored. Okay, press equals 21.0 for confirm. So this is the value we got when we simplify this question. So it's as simple as this. This is the idea of solving problems involving trigonometric integrals, both definite and indefinite, using the Casio Fx-991 ES Plus second edition scientific calculator in seconds for multiple choice questions. Alright, so let's something interesting from this video. Let's quite the video, guys. Don't forget to reset the calculator once you're done. Just press Shift button 9. But guys, feel free to check option B and C. I know that you get the wrong value. The correct option is option A. Alright, so press shift this button 9 to clear. Press 3. Press report 2. Press report again. So that's it.